GCF, greatest common factor. When we think of greatest common factor, which is what GCF stands for, it's important for us to just kind of remind ourselves what a factor is. How would you define what a factor is? Good. So it's not the answer when you multiply, it's what you multiply. So if we had 4 times 6 equals 24, your factors would be the 4 and the 6. The 24 is known as your product. Okay? So when we talk about greatest common factor, we're talking about the largest factor that two numbers would have in common. And the process by which we find that is very similar to what we just did for homework with our factor trees. For example, if I want to find out the greatest common factor between, say, a 6 and a 21, the process is as follows. I will work through my factor trees and I'll say, okay, the prime factorization for 6, when I put them in order, is 2 and 3. They're both prime. 21, 3, and 7. And I list them. Now, those are the prime factors of each. I need to find out which ones they have in common. And according to what I have, it looks like they only have a 3 in common. Therefore, their greatest common factor is just a 3. They can't have 2 in common. Why? There's no 2 for 21. They can't have 7 in common because there's no 7 for the 6. Okay? So we use our prime factorization to find the greatest common factor. Now, that's what you do when they only have one number in common. Okay? For each circle that you make, you write it down. I'm not going to say if they have 2 3s in common. If I said they had 2 3s in common, that would mean the 6 would have 2 3s and the 21 would have 2 3s, but neither of them even have 2. Let's look at another one. How about 20? How about 14 and 20? Some of these you might be able to kind of get an idea right away, like what's the first thing you think of that maybe they would have in common, a 14 and a 28, just by your number sense? Kishana. 2 would be a common factor. Would it be the greatest factor that they would have in common? 14. Any bigger than 7? 14. Let's test it. Let's test it and see what happens. 2 and 7, both prime. Okay. 28, 4 times 7. 2, 2, 7. Now, when you did your prime factorization for today, you used exponents when you tied everything together. For GCF, maybe it's easier if you just do this the long way. You can certainly do it with exponents, but if we're looking for what they have in common, and I can just circle their common factors, say, okay, there's a 2. Anything else that they would have in common? The 7. Now, if I have to write down more than 1, like in this case, I circled the 2, I wrote down the 2, I circled the 7s, wrote down the 7, and I multiplied. 2 and 7, 14. Were we correct? Yes. Our assumption was correct, but we found out, we confirmed it, we went the extra mile. Okay. Any questions so far? Yes, ma'am. 14 would be your greatest common factor. You got it. $16 and 48. So for 16, 1, 2, 3, 4 twos. For 48, 48 is actually 3 times 16. And that's your four-headed monster. Okay, and as I do my comparing, I have a 2, another one, a third one, and a fourth one. Whoops, that's a 3. Third greatest common factor? 16. 2 times 2 times 2 times 2 is not 8. Actually 16. And you know what? You circled everything here. Circled everything there. And you said that was 16, so there it is. Okay? Try one? Sure. All right. How about 72, Maddie? Good. 8 times 9. Yeah, so what's 8? And 9? Yeah, you got to do all that. Same thing you did for your assignment today, right? You did well on your assignment today. Yeah, you just do the same thing you did for today. Now 120. I would just go 12 times 10. 2 times 6. 2 times 3. 10. 2 times 5. It's going to be extremely important to keep track of what you have. How many 2s? 1, 2, 3. How many 3s? And how many 5s? 1. So now, I've got them all listed out. I got a 2. I've got another 2. I've got another 2. And, so the three-headed monster, which is 8 times 3, 24. There you go. 54. 6 times 9. 2 and 3. 3 and 3. So for 54. And for 84. 2 times 42. Do that. It's fine. And then 6 times 7. Okay. So 2 2s, a 3, and a 7. They got a 2. They have a 3. And anything else? 6. 6. 57. Let's go to the 19 first. That's definitely prime. That's on our list. You should have seen it. Now, 57. I'll ask it again. Do prime numbers have a certain look?
Nope.
No. That's why you test them. Is 57 divisible by 2? Is it divisible by 3? Yes. 3 times what?
19.
So for 57, 3 times 19. For 19, 1 times 19. What do they have in common? There's their GCF.
Oh, that's what I did wrong. Yes, I did. I put 17.
I was trying to figure out how you.
She said.
$50. 50, if we're thinking 2 times 25, then for 50 we're thinking 2 times 5 times 5. Now, 50 times 5 is 250. Well, if this is the prime factorization for 50, I'll just need to add another 5 to it, right? So we should have, what? 2 times 5 times 5 times 5. 425. 5 times 5 times 17. Okay, now be careful. They don't have to line up for them to have them in common. So some of you did this. You took those 5s, and you wrote it down, and then you got stuck. Well, there's a 5 here, a 5 there. There's also that one way over here that you forgot about. It doesn't matter. It doesn't matter if they cross over, because it's still a 5 here, a 5 here, and a 5 here. They still have 2 5s in common. Therefore, 25 would be your GCF. Sure, we did this last year. Now, worksheet 3-3. It's your second pink one.
I thought I didn't need it, so.
So I always make plenty extras for 7th grade.
Wait.
17 through 28. Okay. 17 through 28. Obviously, there won't be enough room on there to do your factor trees on the sheet. You have to do them on a separate sheet. Okay. So you have about 15 minutes.